Hey guys, this is Academic Challenge Pre-Calculus, lecture number 11.2, and we'll probably tack 11.3 on at the end since they're pretty similar. So we're going to talk specifically about, we just talked about recursive sequences. This is a special kind of recursive sequence, which is called the arithmetic sequence. So the reason it's significant is, and I shouldn't even say, well, it is. So we have the general term, so we always need to know that general term, and then we need to know this thing called D, which is the common difference. And there's a standard formula for this. So let's just talk about the standard difference for a second. If you're given these particular sequences, all you have to do, as long as it's given already that these are arithmetic sequences, is you just are subtracting the next term from the previous, because you can see every single one, think almost like a linear sequence, so to say. Every single one has a difference of 6, or a difference of 4, sorry. So your first term, a sub 1, would be 6, and then your common difference would be 4. This one, first term is 0, common difference, you do negative 6 minus 0. Remember, negatives do matter, so, and your common difference is negative 6, so that one's going backwards instead of forwards, which is possible. Then you have first term 1/3 for this one, and you do the second minus the first, and your common difference is also 1/3. So that's also possible to have the same common difference as first term. Here's the generalized formula for it. So if you know it is a arithmetic sequence, you can find the nth term just by adding the first term to n minus 1 times the common difference. So you can see here, find the 11th term. So we're going to use that formula. You can see it up here. But the first thing we need to do is find our common difference. So our first term over here is 2. And then our common difference is 6 minus 2, or 4. And then we just plug it all in. So you put your first term here, 2. 11 minus 1 because it's the 11th term we're looking for, and then common difference of 4, and then you just do the math out. You could also work backwards, so what if we wanted to figure out what term 302 is? So you would set that formula we just found equal to 302. Because we don't know what term it is, so n is unknown, but we can plug it all in the formula since we already know the first term and the common difference. And then we solve that formula for n, and out comes 76. So it's the 76th term. Find the third term of the arithmetic sequence, or we have the third term and the 9th term. Now we're looking for the first term and D, the common difference. So a little tricky. What you're going to do is take that 9th term, so that 9th term is your 37, there's your 9th term, and then your third term is that negative 5, and find the difference between them. Because again, this is kind of moving in a linear fashion. So if we have that total distance between them, and we look, okay, what's the difference between 9 and 3? That means there's a difference of 6 terms. So if we have the total distance and we divide it by 6, then we get the average distance, or which will give us the common difference, because again, it's linear. So our common difference is 7. So what about finding the first term? Well, we're given the third. Now that we have that common difference, all we have to do is go negative 5 minus 7. That gives us our second, and then negative 12 minus 7. That gives us our first. And then at the very end down here, you can see here is our, sorry, I'm trying to not only draw, but draw with my left hand, and I'm right-handed. Let me switch out here. So there you have it. So we can also find the sum of the first n terms of an arithmetic sequence by n over 2 times the first times the, or first plus the nth. So find the sum. We just, first of all, would need to know the 11th term. So once we find first is 16 and the common difference is negative 4, we once again plug that in and find the 11th term, which is our negative 24, and then we plug that in. So we're looking for the sum of the first 11 terms, so 11 over 2 times 16, because that was a sub 1, and then negative 24 was our nth term, and we get negative 44. This one's a little easier because it's already in its formula, so we're just looking for the first and the 10th. So it's the partial sum from 1 to 10. So find the first term, 10th term just by plugging 10 in, and out comes this formula. So we plug in the first and the 10th, and we get 590. So word problem. So this is a orchestra. There's 8 total rows. The first has 5, second has 7, third has 9, and so forth. So how many musicians are in the last row? So we know there's 8, and we know that we can see quickly that the first row is 5 over here, and then the common difference is going up by 2. So we have that common difference. So this first part, part A, we're just looking for what is the number of musicians in that 8th row. So the 8th term, we plug it into our formula, and out comes 19. For part B, we want that partial sum. So we already have the pieces we need, so it's just 8 over 2 times 5 plus 19, and it gives us 96. Okay, and finally for 11.3, this is geometric sequences. So another special kind of sequence, and like the last one we had a common difference, now we have this thing called the common ratio. So the common ratio, if you were to take the next term and divide it by the previous term, it should always equal a set number, and that's what makes it a geometric sequence. So just like we found the common difference by subtracting, now let's find the common ratio of these geometric sequences. So you can just take the next divided by the previous. So 16 over 4 gives us 4. Negative 2/3 over 1 gives us negative 2/3. 600 over 750 gives us 4/5, etc., etc. So in order to find the nth term, we have this set formula. The big thing to notice this n minus 1, that is important up there, because the first term is usually going to be 1. And then we have, or not 1, but whatever a sub 1 is. So it has to be n minus 1, or else it's not going to show us what that a sub 1 is. So find the 11th term. So all we're doing is plugging it in. We look at this and say, okay, well, what is our common ratio? It's negative 3. So we can plug it into that formula. The first term was 1. So we have 1 times negative 3 to the n minus 1. And when we plug it into the formula, we get a nice big number. Then we have find the nth term. So this one, just always watch out. So that first term, just envision, okay, well, what if 5 was to the 0 power? Because we're starting n minus 1, so it's 4. And if you look, 4 is common. So if I factored out 4, this would be 1, this would be 5, this would be 25, etc. And we can see that pattern of the 5 to the n minus 1. So once you find that, to the 7th one, you just plug a 7 in, and out comes that number. A lot of these you're going to need the calculator to solve out at the end. And the neat thing about this, too, is just like the arithmetic, we can also calculate the partial sum pretty easy. We have a formula for it defined by the first term and the common ratio. So this problem, I did notice that that's a k, not a k minus 1. It has to be k minus 1. So we do this little algebra trick here. So 2 times 3 to the k is the same as saying 2 times 3 to the k minus 1. Because you're just taking one of those k's away. If it's 3 to the k and I pull 1 out, well, then you're left over with 3 to the k minus 1. If k was 5 and I pull a 3 out, then you would have 3 times 3 to the 4. So it makes sense sometimes when you see that illustration. But what this does is it puts it in its standard format, because before we would have guessed and said, oh, a sub 1 is 2. Well, it's actually not. A sub 1 is actually 6, because that has to be the first term. So we plug it in the formula. 6 goes here first because of the a sub 1, and then 1 minus r. So our common ratio is 3 to the 12, because we're looking for the 12th term, and then divided by 1 minus 3. We get a really big number. And just another example. Is that the one we just did? No. Might have gone backwards. Oh, the sum of the first 7 terms. So, again, just like that first one we did, you pull out the 3. That's going to be your first term. And then your common ratio, 15 divided by 3, gives you 5. And I forgot to say that too. Sorry, I said factoring in the other one, but the easier way, again, just remember you can always find that common ratio by doing the next divided by the previous. So first term is 3, and then 15 divided by 3 is 5. So it's an easier way to think about it than factoring, especially if you don't like factoring. Then we have the sum, so we can talk a little bit about infinite concepts with geometric series, because if that common ratio is less than 1, it's actually going to start to come to a set number, and we call it convergence in calculus. You'll learn when you get there, but these little shapes kind of make a idea. So if your first partial sum was a half, and then 3/4, and then 7/8, and so forth, you can see how you're slowly getting smaller and smaller, but you're going to approach a number. So what ends up happening is we have this rule, and you'll actually prove it in calculus, and it'll make more sense. But we can talk about what's called the limit, or the sum of an infinite geometric series. If that common ratio is less than 1, meaning the absolute value of it, then the limit of the sum, or the sum of an infinite geometric series, is just the first term over 1 minus the common ratio. So for these last two examples, we look at it, and this one here, we can see quickly the common ratio, 6/3, gives us 2. So it's bigger than 1, so that means there's no limit. It's just going to get bigger and bigger. This one here, we have 4, when we do -4/3 divided by 4, we get -1/3, and remember, it's absolute value. So it's less than 1, so it does have a limit, and we just plug in those values of the first term divided by 1 minus the common ratio, and we get 3. So it's kind of neat. If you added all those up, it would come to 3. And we'll end with these word problems. So we're talking about a ball hitting the ground and it's bouncing. So just notice that 27, I circled it, and I wrote 54 because we're talking about rebound effect. So it's going up and then down, up and then down. And every time it goes up and down, it's 2/3 of the distance of the previous rebound. So we want to know the total vertical distance the ball traveled when it hits the ground the 10th time. So a sub 1, when it hits the first time, would be 54, or double how high it went. And then our common ratio is 2/3 because it's getting to be 2/3 that distance each time. So we plug it in that formula. Here's our a sub 1. 1 minus r to the 10, because we're looking for the 10th time, and then divided by 1 minus r. And we get our solution. And then finally, this is my favorite problem of the whole semester. When you look at this, suppose someone offered you a job for 30 days, and you look, and the first day you're going to get paid 1 cent, and then the next day 2 cents, the next day 4. So is it worth it? And obviously you can see from the solution, yes it is. But it's really kind of a neat problem. So your a sub 1 is 0.01, and then your common ratio, if you look at it, is 2. So again, it's kind of a good illustration of why we can't talk about the limit of an infinite series, or of a geometric series, when the common ratio is bigger than 1, because it's just going to get huge very quick. So when we plug it in and find that 30th partial sum, you can see that suddenly that top, I mean, once you hit that whole number, it's just going to multiply really quickly. So, and we see that you end up with 10,737,418. So definitely a job. If someone offered it to me right now, I would take it. So, all right, guys, have a good day. And I went fast on this just because my phone doesn't have a lot of memory. Hopefully it makes sense, and if not, we will discuss it further in our Zoom sessions. Have a great night.